In this problem, we're going to look at another situation that will involve a chi-square test for homogeneity. So Jenny makes a six-sided die in her ceramics class and rolls it 60 times to test if each side was equally likely to show up on top. So in other words, trying to test if she's made a fair die. And the table shows the results. Now let's assume the conditions for inference are met. What would be the hypotheses that Jenny is interested in testing and the evidence for the alternative? All right, so Jenny would be interested in testing a null hypothesis that the die is fair. All right, so in other words, all sides equally likely to occur. Right? Or that we could say we have a uniform distribution of sides occurring. All right. So the die is fair if all sides are equally likely to occur. Okay. Now, what would be the alternative hypothesis? The alternative hypothesis would be the die is not fair. All right. And what would be our evidence? What would be our evidence for the alternative? All right. Well, the evidence is that number one occurred more than twice as often as number 3 in 60 rolls of the die. All right, so number 1 occurred 13 times. Number 1 occurred 13 times, while number 3 only occurred 6 times. So that would be our evidence that the die is not fair. Okay, now we want to calculate the chi-square statistic, right? And in order to calculate the chi-square statistic, what we have to do is to come in and say, okay, well, we're going to need our chi-squared is going to be a summation of my observed minus my expected squared all over my expected. All right, so we're comparing how much do I expect to have in terms to how much I actually observed. So in this case, if the die is fair, then all the outcomes are equally likely, which would mean we would expect to have 10 outcomes for each of my die faces, if it's fair, from 60. All right, so what would that summation be? That summation would be, we just need to show the first few, right? I have 13 minus 10 squared all over 13 plus dot, 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 and then plus 8 minus 10 squared all over 13. All right, and we're going to let our calculator do the rest of this work for us, but we'll get to that in a moment. Okay. Then we also want to determine our p-value, right? We also want to determine our p-value, right? And in order to determine the p-value, we are going to need to know that chi-square statistic. So I'm going to write this like this. The p-value, right? That p-value is going to be the probability that chi-squared is at least, right, whatever value we happen to find for our chi-square statistic, and it's going to be based on some number of degrees of freedom. Okay, well, what are going to be my degrees of freedom? Well, I've got 1, 2, 3, 4, 5, 6 categories. And so my degrees of freedom would be 6 minus 1. My degrees of freedom would be 5. All right, so I'm going to let my calculator do this work for me. I'm going to let my calculator do this work for me. So let's go ahead and bring the calculator over. I'm going to turn on my calculator, and I'm going to need to go into Stat, Edit, and enter in my actual outcomes. So 13, 11, 6, 12, 10, and 8. All right. My expected values, each of them was 10. All right. And then I can hit that Stat button. All right, I can hit that stat button and arrow over to tests, and I'm going to have a chi-square test for goodness of fit. So the chi-squared GOF test there, right? So I'm going to go ahead and slide this up, all right? So that chi-squared GOF test, and I press enter. List 1 is my observed, list 2 is my expected. My degrees of freedom, right? We said 6 minus 1. And then we're going to come and we're going to calculate. And so we see our chi-squared value. It's a little bit tough to tell. Let's see if we can autofocus this to get a little bit better. All right, so we have our chi-squared value of 3.4, and we have our p-value of 0.6385. So we're going to go ahead and write that information down. All right, we found a chi-square value that if we did all of these summations, that chi-square value was 3.4, and the probability of getting a chi-square value of 3.4 more when the degrees of freedom is 5 is going to be 0.63. Let's get that right a little bit better, 0.6386. So in other words, right? So in other words, what we've got is we have the 63% probability, assuming that all sides are equally likely to occur, right? So assuming that null hypothesis is true, about 63% of the time we'd get a distribution like our observed values or more away from a fair distribution, right? So it's very likely to have been due to chance. And so what's our conclusion, right? Because the p-value is greater than 0.05, we fail to reject the null hypothesis. We do not have significant evidence to tell us the die is not fair. Okay. Now, if that is an error, right, what type of error do we have in context, right? So we would have a type 2 error would be possible when we fail to reject, right? So therefore, we play with die as if it were fair, but in reality, the die is not fair, okay? So that is the general approach for all these chi-square tests for goodness of fit. All right, you have to be able to identify your null and your alternative hypotheses. You have to be able to compute the chi-square value, and you're going to let your calculator do that, but you're going to show the setup. You have to be able to compute the p-value, and once again, you have to understand what it represents, the notation. You're going to let the technology, the computer, your calculator do that. And still the same information for rejecting and failing to reject and working through those items. Okay? As always, as you need, please ask questions for clarification.